Hi, this is part 2 of the 6502 Logic Analyser overview. I'm going to just run the analyzer, collect some data, and then run it through the trace program to show how it can disassemble and show you all of the opcodes and instructions as something executes. So first thing we'll do is start the little command line program on the Linux server that actually talks to the teensy computer and allows us to set the trigger address and set it to run. So there's a trigger address set to A000 address, and we'll type run, and then I'll hit the reset switch, and that means that the teensy found address A000 and it recorded the next 5,000 address and data combinations, and we can show that by just displaying a few of the address and data and the control signals there. So in order to upload them to the Linux server, we use the dump command, and we just type file name. I'll just use file 1. And that uploaded and stored those in file 1 on the Linux server. So I'll quit the command line program, and as we can see, file 1 has arrived. So then I can use my trace 65 on file 1, and it will go through the file and disassemble and show you all of the opcodes and instructions that were executed, as well as all the reads and writes. And so let's just save that to a file, and we can edit the trace 1, and you can see here that these are all of the opcodes being executed. It shows the load store. This is going through an initialization, so there's a lot of loads and stores going on. So for example, on this line they're loading 00 into the accumulator, and then they store 00 at F802. So you can see the address F802 came out as the next address on the data bus, and the dash sign is just the way I'm showing that it was a write, and that was to 00. And then it loaded C0, and it stored that at address, this is a 0 page store, so it came out at 0020, and it wrote C0. And it goes through like that all the way through. You can follow the flow of the program. You can jump around using your favorite editor and see what happened next, one after the other. And it shows, in this case, it's doing a jump to service routine. And in that case, it writes to the stack, which is on page 01. It writes the return address of A091. So, and then it jumped to that service routine. So that's kind of how the thing works. Is the teensy runs the code that monitors the address and data, collects the data. The Linux command line program allows you to control that, as well as upload the data onto the Linux box. And then I have a trace program, which is really just a disassembler that steps through and traces and shows all of the opcodes and the flow of the execution and the reads and the writes to memory. And now I just have to fire up the old Ohio Scientific computer and see whether I can actually use this to diagnose the problems with it. Thanks for watching.